Now to introduce our seminar speaker this afternoon. Dean Johnathan Overpeck is the Samuel Graham Dean of the School of Environment and Sustainability, the William Strapp Collegiate Professor of Environmental Education. Dean Overpeck is an interdisciplinary climate scientist and has active climate research programs on 5 continents. His research focuses on understanding the drought and megadrought dynamics and risk world over. His talk today is focused on the Great Lakes, which there's been a lot of press recently on issues with the Great Lakes in terms of depth and rainfall and such, and this year actually no ice. So I mean there are a lot of issues around the Great Lakes, so I think the talk is going to be both especially relevant for us, but the Great Lakes are a vital resource for certainly the region and probably the world. So Dean Overpeck, welcome and thank you. We look forward to your talk.
Thanks. Thank you. It's a real pleasure to be here, and it's good to know if I need a transplant, I'm covered. Don't laugh. It happens, right? I spend a lot. Oh, I can walk around. That's a hint. All right. There we go. Can I unplug it? No. I can't walk around very far, though. But it is nice to be able to hold this thing. I was told when this was negotiated a while ago what I would do when I came here, and then, of course, I forgot. And it's been very kind of everyone to help me catch up. But I was told originally, dim in my mind, that people want to know about SEAS, the School for Environment Sustainability, which has been around for 5 years now, but it's built on the School of Natural Resources and the Environment, which was built on the School of Natural Resources, which was built on the School of Forestry and Conservation, which was built on forestry. And if there's anyone here who really knows the true story, keep quiet. But essentially, the school goes all the way back to when University of Michigan was leading in the nation in putting together a school that would help clean up the mess we were creating in the early 20th century when we cut down all the trees in eastern North America to build everything. And it just left behind, anyone's been to a big clear cut out west, you know what I'm talking about, left behind just a mess. And it had to be, these ecosystems had to be restored and for animals, for fish, for everything. And the school was created to help do that, as well as manage our forest resources more equitably and effectively. But anyhow, I came back to Michigan. This is important to know, that I grew up here. I got married on the shores of Lake Michigan. But then I went west. First I went out to New England and grew up some more. But then I went west and been out there for a long time and came back here for this position, this job, this new school, this opportunity. And anyone who heard the inauguration speeches that our new president has given, I get a sense why I came back, because this has been building for a while before me, but my goal in life is to do more in academia for society and to see if we can change academia to be more responsive to the needs of society. And my field is climate change, so that's one area where I feel very compelled to do something, and hopefully I do feel all my colleagues, not all probably, but many colleagues across campus, certainly all my dean colleagues, we all feel like we need to work together on this topic and several more, really having hopefully an outside impact in society, moving the needle on some of society's greatest challenges. So what I want to talk to you about today are the 2 things I was asked to talk about. One slide only on seas, and then the rest is going to be on climate-related things, including in the Great Lakes. So next slide, please. And a lot has happened in this school. My colleagues are outstanding, and it's the most interdisciplinary school I've ever seen. That's one of the reasons I came to Michigan, and all of you probably can imagine some of the other reasons, not just that I like the Great Lakes, but for those of you who are keeping track of these things, our undergrad program now with partners in 5 other schools and colleges, primarily LSA, but not just, We're up to 350 majors. I think this is going to start ballooning as President Ono really elevates environment sustainability as major themes that cut across campus. Our master's program, professional master's program, has already more than doubled. We're up to we have a standing stock of master's students. It's about 500 or 600 now. We're doubling our PhD program in part because we had to really grow our faculty to support all these master's students and undergrads. And our faculty is very research active, so they want PhD students. So we have a lot more PhD students than we used to have. About 50 faculty, but we actually have a lot of lecturers, professors of practice now, and so clinical faculty, and a lot of joint faculty from all across, 5 or 6 other schools across campus. And so we have about 90 total, but about 50 tenure track faculty. And out of those 50, we have 4 National Academy members. We didn't have any when I started, and I'm not taking any credit for this, of course. This is the quality of our faculty. But now per capita, we have more than any other school or college on campus. And we also have 4 faculty, probably more than any other school or college, working in the Biden administration in important roles. And we're number 3 in terms of research dollars per faculty member across campus, behind public health, who's number 1, and engineering is number 2. And so we're really research active. But like I said, our big take-home message, if you want to remember anything from Seeing Peck Talk About Seas, is that our goal is to be much more engaged in society, helping people in society with their problems, for example, dealing with climate change and many other things. Okay, that's that. And if you have questions or anything, we can talk after the talk. This is what I wanted to talk about today. How many people have heard me talk before? Anyone? Okay, a few people. Okay, so I had to do something different, right? There'll be some similarities to some of the talks I've given a lot, because everyone wants to know how climate change is affecting the Great Lakes region and the Great Lakes themselves. But this was just published, and I thought this would be a great slide. This was in USA Today, so a national newspaper. What a title, right? Drain the Great Lakes. And so the reason I told you I grew up here and I got married on Lake Michigan, have family on the Lake Michigan coast and stuff, is because I wanted to highlight I am not a spy from the Southwest. Right? I'm not here to give away the water. I'm here to help protect the water. And indeed, we have faculty that I've helped hire who are leaders in understanding the hydrology of the Great Lakes and the policy related to the Great Lakes to ensure that we can keep the Great Lakes great. And in fact, make them greater because they're already heavily threatened by a number of things we'll talk about. Right? But I want to talk to you about what this problem is, because this is not something to laugh at. People in the Southwest genuinely think that they can just continue their merry ways, wasting a whole lot of water. I almost said a bad word. And that some other people will bail them out somehow. The federal tax dollars will bail them out. Can you imagine building a pipeline from Phoenix to here? How expensive that would be, and let alone what it would do to the Great Lakes. But we'll talk about that. Just to sort of get ahead of myself a little to make sure no one here needs that transplant during my talk it ain't going to happen, okay? But there are going to be people who are going to try. If you read this article, it's one of my colleagues, a very famous hydrologist. He's in Canada now, but Canada's going to be the ones who stop him too if we don't. But the point is, a lot of my colleagues and scientists who are kind of disconnected from reality, they're in the lab, they have all these great thoughts. We're really smart, aren't we? And I know a number of you are probably former faculty. I'm poking fun at us. But the point is some of us go a little too far. So let's see what's up with this. I want to explain why we have this kind of thing popping up again. It was popping up all the way back to when I moved to the West 30 years ago. And it's a lot of people actually think this. Okay, next slide. But the first thing I want to do is get everyone familiar with climate change. I'm not going to talk about is it real, or what causes it? Because I hope everyone here knows that and knows how to use the web if you don't. What I do want to highlight is that we're getting a lot of extremes in our climate system now. I don't know how many people read this week, northern Greenland is above freezing now. It's crazy, okay? That ice sheet is, if we're not careful, toast, as is Antarctica, and that'll mean we'll be very happy living far from the coast of the ocean. But we're getting lots of wildfires out west. I'm going to talk a little more about that. One of those pictures is from Australia. A couple of years ago, they had just an amazing fire season. Bushfires there, not wildfires. Just kidding. That's what they call a wildfire. Heat waves. Last year was like a poster child for heat waves, all the way from China through India and Pakistan into Europe and here. People dying in unprecedented numbers because of heat. And then I'm going to talk a lot about the Megadrought that's going on in the West, the reason people are starting to look for water. But I also want to highlight in this talk things like hurricanes and the untold damage that they're producing now because of climate change, right? Much greater than before. What do all these things have in common besides climate change? This is important. Next slide, please. The important thing to realize is that the intensity and the severity and the costs associated with all these climate extremes is going up because it's warming. Warming is causing that problem. And the reason I'm highlighting that is because we know with pretty much near perfect confidence, never know anything in science with absolute confidence. I mean, although I could drop an apple here and we all know it would go down, I'm talking about that kind of confidence, okay? That warming will continue as long as we elevate the greenhouse gas concentrations, the CO2 and the methane in particular, mostly caused by burning of fossil fuels. As long as we keep doing that, it's going to get warmer. And now in the scientific community, my community, we've connected all these climate extremes to that warming. And so we can't say an individual event was caused by climate change, but we sure know that all of these events are going to be getting worse because of climate change. Next slide, please. And how much climate change have we had so far? Some of you who follow this whole issue know that the nations of the world, all 196 of them or so, agreed in Paris several years ago that we would limit global warming to 1.5 degrees C or 2 degrees, somewhere in that range. Sorry to report this, but we're not going to limit it to 1.5 degrees. If we're lucky, we'll keep it under 2 degrees. So far, we've warmed up, as you'll see in the next slide, a little over 1 degree C. So what I'd like to do is go backwards one, please. Thanks, sir. And just highlight, though, that this is 1 degree global warming, the warming that's occurred since 1880. And of course, the warming began before that at the dawn of the Industrial Revolution. But most of the warming it's just been accelerating since then. And this just shows you the array where we had a global array of thermometers, so we're able to look at the map. Wherever it's gray, we didn't have thermometers back in the late 19th century. But you can see the warming isn't uniform across the country. In fact, in the North Atlantic, as predicted, it's cooling. But everywhere else, pretty much, it's warming. And at the higher latitudes, over land, it's warming more than over the oceans. And that's, of course, a problem because most people live on land. All right? So the idea here, in my mind, another take-home is we're probably going to get double the warming we have now if we really start to kick tail on solving the climate crisis. And this is one of the things the University of Michigan is going to help do. And we're going to try and get every other university to help us. But hopefully we'll be able to limit it. But that means double the severity and the number of these extremes that we've seen so far, particularly in the last 5-10 years, where they're really starting to kill a lot of people and cause a lot of hardship around the world. Skip ahead 2 slides, please. What I want to talk about today, though, is the hydrologic cycle. And my point, again, is that the hydrologic cycle, all the things in this picture, which you in the back of the room probably can't see at all, but the rain and the snow and the evaporation and the evapotranspiration from plants, everything in the hydrologic cycle is being supercharged by, someone say it, warming. Yes. And the reason for that is we knew from theory long ago, and now we can measure it. It is happening. For every degree C we warm the atmosphere, we get about a 7% increase in the moisture holding capacity of the atmosphere. So it's like we're getting an atmosphere that's a sponge, and we just are upgrading to bigger sponges constantly. And that means the sponges can soak up more moisture, and they can, when squeezed by the right meteorological conditions, can dump more moisture. Not only dump more moisture, but dump it faster. Okay? All of you have sponges in your kitchen. You can do an experiment. Take the big sponge and the little sponge, and you'll see what I mean. When you have a big mess, which one do you want to use? Right, the big one. But when you want to really get the water all over the place and really clean up, you want to squeeze that big one too. And that's what we're doing with global warming. So let's look at the implications for that. Next slide, please. So this means, one of the things it means, and this is why they're clamoring for our water, is that the more it warms, the more atmosphere can hold moisture. Over the ocean, of course, unlimited moisture. But over the western United States, not so much. Although you'd find that hard to believe right now, where it's snowing cats and dogs. But that moisture came from the Pacific Ocean. So normally what's going on in the summer when it's really hot, in the spring and the fall, you're getting a lot of moisture demand from the atmosphere, which is hotter than it was before. And where can it get that moisture? It's going to get it from the land surface, it's going to get it from reservoirs, it's going to get it from plants, it's going to get it soil, it's going to get it from wherever the heck it can go get it. And we'll see what I mean in a minute. Next slide, please. This means more drought. And here's a summary of where the water's coming from. Next slide, please. Next one. The atmosphere warms up, needs more moisture, demands more moisture. These are the primary ways that out west, more moisture is ending up in the atmosphere than on the land surface or in the land surface than before because of the warming. Of course, we're getting more evaporation. We're getting more sublimation where the snow is basically going straight from frozen water to water vapor in the atmosphere. The biggest term of all is evapotranspiration. Everyone in the room of gardens knows what I'm talking about here, or midsummer in Ann Arbor. Evapotranspiration, all these plants we have, natural or otherwise, all have little pores in their leaves to exchange CO2 and oxygen, photosynthesis. But constantly, when those little pores are open to get the gases in or out, they're losing moisture. And the hotter the atmosphere is, the more moisture is being lost. So it's a conduit for moisture in the soil brought up by the roots through the plant into the atmosphere. And the evapotranspiration is really the reason behind all the wildfires and the dead trees out west now. Trees are literally being sucked dry, and they're dying. And they're succumbing. If they're not sucked dry, they don't have the sap potential anymore. They're getting insect infestations, or they're burning up. Okay? And the growing season has gotten a lot longer because of the warming. So the spring is coming earlier in the west, and the fall later. The growing season's already grown by 6 weeks out west. So the evapotranspiration season, when plants are growing, has grown, and that means more moisture going in the atmosphere. So that's how the warming takes its toll on our west. Next slide. This shows you beginning of the what we call the water year out west. The water year begins October 1. It's really when snow starts to fall, and we start to get a net accumulation of water in the rocky, in the mountain west. And then that snow, of course, accumulates, we hope, all through the winter, and then it's melting and providing water for all sorts of things, plants, reservoirs, rivers, you name it, all the way through most of the summer. And that's getting tougher and tougher as it gets warmer because of the processes we just talked about. So this drought started in, when I moved from Boulder, Colorado down to Tucson, Arizona, in 1999. And it's been going on since then. Some years, some seasons, we've had good snow, not so many. and rain. It's all about snow. And some years we've had more than good. We've had bad years of snow. Okay. If you go to the next slide, please, you can just see how the drought has kind of moved around over the years. Just looking at a couple other years, 2002 and 4 were exceptionally bad in the Southwest, in the Four Corners, Arizona, New Mexico, Colorado, and Utah. Large expanse of pinyon juniper forest or woodland became just juniper woodland. All these pinyon pines just died because there wasn't enough moisture. Now, then a lot of them burned up since then. And it moved out into the plains in 2012, looking kind of like a dust bowl, down into the 2013, looking like a 1950s and 60s drought, which was the worst drought in the Southwest until this current one. Okay. And then the next slide is just what it looks like now. The most recent drought monitor. These are come out every 2 weeks, thanks to NOAA and University of Nebraska colleagues. And it's really interesting. The drought has been ameliorated. We're having a hell of a snowfall out west now, and you hear about California all the time, right? But it's also been snowing a lot, particularly in Utah and western Colorado. And that big swath then of gray that goes right up through Four Corners is because of all that great snow. And the drought monitor, as they call it here, is monitoring present day conditions. Okay, so this is really meteorological drought. And it's gotten a lot better, unless you're in Texas and the high plains. We'll come back to the high plains. They're part of this story too. Next slide, please. Okay, this drought, though, has been investigated now by many scientists in the peer-reviewed literature, and it's pretty established, it's very well established, that it's been made a lot worse by the warming. And this work was done by colleagues primarily at UCLA and I think Columbia University and University of Arizona, where I was. But they've studied the drought, and on the right you see two maps. One shows what the drought is observed in. This is looking at soil moisture as one measure of drought. And then this other map, which looks a little less red, using climate models and land surface models, they've determined that's what the drought would have looked like absent all the warming. So you can see the difference there. And the difference is about 42%. In other words, the drought is 42% worse, drier, soil moisture less, because of the warming. The time series on the left is constructed using tree ring data. And fortunately for us, anyone studying climate in the West, we have amazing trees out there. They're living forever, and boy, do they feel climate one way or the other. So you can reconstruct all sorts of things using tree rings. And in this case, you can just see smooth record of soil moisture going back 1,200 years to 800 AD on the far left, and then going up to the present day. And you can see the severity of the various ups and downs, and you can see in red the instrumental record overlapping with the tree ring record, and they actually match where they overlap. But over this area in that yellow box on the map, you can see that the current drought is more severe than any drought in the last 1,200 years. And we've had other major droughts, long droughts, but this is the worst one in 1,200 years. And we're now in the 23rd year of the drought, maybe 24th. Started in 1999. Okay, next slide, please. So this is not just a meteorological drought, maybe made a little better this year by all the snow, but it's also an ecological drought. And the plants and ecosystems average over more than just one season. And so this is why the soil moisture in the West has been driven down, down, down. And we get a good snow year and it comes up a little, but it's trending down. And of course you can only go so far with soil moisture, right? Before you're out. And then you're in Arizona. No, I'm just kidding. Not really though. Those of you who go to Arizona know there are a lot of mountains and they have nice trees on them. But when you're down in the lowlands, it's desert and the soil moisture is very low. But anyhow, this is draining the soil moisture everywhere across the West. And one of the implications of this is the dead trees I've mentioned, and the other is the fires I've mentioned. And it's unprecedented now. This is the fire out near Big Sur last winter. In the winter, you're getting unprecedented wildfires now because of this drought. In the winter. It's just bizarre. I mean, the fire season out west, when I moved there, it just moved north out of Arizona up to Montana and Canada and then moved back. Now it's just all year round. Okay, of course, we're getting a little break this winter because of all the snow. Next slide. Thank you. It's also a hydrologic drought. And so just like ecosystems integrate over longer periods of time, hydrology also integrates, especially in the West, where we've put in place these amazing infrastructure to get through drought without noticing the drought. And by that I mean a lot of dams and a lot of rivers, like the Colorado. And that's what I'm going to talk about now. And what's the big reservoirs in the Colorado, I'll show you where they are in a sec. These two biggest reservoirs in the country, Lake Powell and Lake Mead, are now about a quarter full. And that's why we're getting headlines that say, let's go drain the Great Lakes. Because these reservoirs are critical for water supply. They're critical for all our vegetables that we eat except asparagus in winter, because they're grown in southern Arizona and southern California, Imperial Valley and along the Colorado. They're really critical, all this water for power generation. It's green, it's clean, no carbon emissions, and a lot of people depend on that power, priced very cheaply. Live in the West, nothing is like in Ann Arbor. Everything's way more cheap. So you retired here, and I will retire here too for other reasons. But the point is, it's cheaper out west. And part of the reason for that is this kind of infrastructure. Okay? And it's all at risk now. And the state's been asked by the Secretary of Interior, our former governor, to figure this problem out. And the states, 7 basin states, have failed. Let's look at the next slide, please. Here is a map of the Colorado River Basin, and you can see those 7 states. 7 states in Mexico share this water, about 40 to 50 million people. LA, San Diego, Albuquerque, Santa Fe, Denver, Salt Lake, they all get water from this river. It's pumped out of the basin. The colored area is the basin, and of course Phoenix and Tucson are in the basin. Doesn't really matter though, the water's been divided up among the states back in the 1920s. You probably didn't notice, and I forgot to point it out, 1920s were the wettest time in the last 1,200 years. And that's when we divided up the water, and we've essentially divided up about 20% more water than exists on an average year before climate change, and now it's just getting worse. Okay, there's where Lake Powell is at the border of Utah and Arizona, and Lake Mead over near Vegas. Vegas also gets water from this river. All right, and you can just see the list of all the things that rely on this water. It's a lot of people and a lot of things. Rely on water from this river, and it's drying up. Next slide. And it's drying up not just because of climate change, but because it's over allocated and people are using more water than there is. So of course that over the years draws down the reservoirs. And so this is starting in around 2000. Science in 1999. I went to Las Vegas when I first moved to Tucson to give a talk to the Southern Nevada Water Authority meeting on the Colorado and its future. And then the Southern Nevada Water Authority was run by an incredibly smart woman who knew that climate change was a problem. And out west, even in California back then, people were not taking climate change serious. And the reservoirs were full. And I came and I talked about climate change and Megadrought, and multiple people in the room were laughing at me. Not in a mean way, but in a okay, Peck. And that's my introduction to the Southwest. So I put a hex on the river, and it immediately dried up. But anyhow, I had nothing to do with that. I've been spending my career telling people, explaining, using the record of the past, that this is going to happen. You know, our models are good, our observations, our theory, everything we know about the river is good stuff. But no one really was going to believe you until it actually happens. And that's a problem with climate change, right? Because a lot of the things we warn people about aren't going to happen right away. They're going to happen down the road. And that makes it a much harder policy issue. But we've had about 20% decline in the flows of the Colorado now. At least half of that's due to warming. Okay? And I've written, with teams, I don't want to take all the credit, but we know what's going on there really well at this point. Many peer-reviewed papers. But in the beginning, we were saying this stuff, and even my scientific colleagues were like, Peck doesn't know what he's talking about. Next slide. Okay. We predicted, particularly in a paper that is widely cited with Brad Udall in the lead, that this will lead to about half of the water in the river being gone by 2050. We're already at 20%. And more if we keep warming. Okay. Well, of course, we're not going to keep warming, right? Please. Next slide. Even when we said that in the literature, I got colleagues, friends, hard to believe they're still friends, telling me, in front of scientific audiences, don't believe what Brad and Peck are saying, or these other guys. I mean, there are multiple groups who are saying this. And because it's going to rain more, and rain doesn't matter to this river. The river couldn't care less about the rain, but it's going to snow more too, and the river does care about snow. So don't worry about it. And then we were like, okay, here's the deal. It's true that we have many models that simulate what's going to happen in the future. They all simulate warming everywhere, except in the North Atlantic. But these models differ in how they simulate the hydrologic cycle and whether it'll be a net increase in precipitation, snow, or decrease in the Southwest. Half the models said increase, half the model, well, not half, but a third say increase, third say decrease, and the other third says maybe no change. But it's important to realize how scientists operate. Some scientists are like, well, we'll just average them all together. And this is the consensus way to do it. I think the reason for that is because no one wants to call the other person's model a piece of whatever. Instead, we want to say everyone's model is good, kumbaya, we'll just average them all. But there are other people like myself and my colleagues I work with who say, well, let's look at the models that actually simulate the observed record well and simulate the processes that are really key to the Southwest, like El Nino and La Nina and some of these other phenomenon that if you don't get them right, there's no way you're going to get the precipitation of the future right. And you look at those models and they don't say there's going to be any change, or they say maybe it's going to be a decrease. But then you say, forget about the models, let's just look at Mother Nature. What does Mother Nature say? Because she gets the last say in all of this. And there hasn't been an increase in precipitation. The precipitation has gone down. Well, fast forward another 10 years, and even the most recalcitrant colleague is now saying, of course we knew the precipitation was going to go down. Okay? So it has. Next slide. But I made the point back then, when there was still contention about the precipitation and what it would do, that, hey, it doesn't really matter. You're still going to be yakking about taking the Great Lakes water. Anyone want to guess why? There's lots of it for sure, but why is it the South? I could say with confidence, even if precipitation goes up, mean annual precipitation due to climate change, which it's not, even if it was going to go up, you'd still have a water problem in the Southwest. More money and more people for sure. But the big reason is it's megadrought country. Okay, if you remember that slide I showed you before, next slide, please. Let's go next one, please. This was that left-hand graph time series I showed you before. Shows that the current drought is the worst one in 1,200 years. But there are other droughts. In the Southwest, these have happened over and over, even before climate change. So these droughts were precipitation droughts. Some in this graph, the longest ones lasting almost 70 years. And we now know the longest drought, the worst drought of all, occurred back during Roman times. There was a drought that lasted 50 years with 1 year where it was above normal. And the water managers of the West were like, speechless, because they could not see a way through that. And the point is even if precipitation goes up, mean annual due to climate change, when you're in a drought, by definition, one of these droughts, precipitation's dropping out. We don't really know why these megadroughts happen. Our climate models, we cannot simulate these megadroughts, but they have happened, and they've happened over and over and over. When it's warmer, when it's colder, they just seem to be ubiquitous, and they seem to be more severe when it's warmer. So temperature is probably playing a role in some of these past droughts. But you get one of those, and you get the warmer temperatures due to climate change, and it's like caca. Next slide. Okay. So is this just a drought that's going on out west? No. Some people are saying no, and you're right. A drought of yore is a drought which starts, then the rains come, and it's over. Dust Bowl was like that. The 50s, 60s drought was like that. Everyone out west is like, well, we just have to wait this sucker out. And I think that's one reason why the states decided to give Secretary Granholm a little less respect by not listening to her and not coming up with an agreement to cut water, because all of a sudden it's snowing like mad. It's going to be great again. And that's the politicians. The water managers are like, oh, God, here we go again. You know, because it's just going to be made worse if we don't start acting sooner. And it's going to be a real mess. And so we're going to have to figure out what to do. We'll talk about that in a minute. This is not just a drought. Next slide, please. This is what we call aridification. And we coined that term in a paper we wrote again, just a couple of years ago. And it's happening around the world. It's happening here in Michigan. Those of you who pay attention to our dry spell in the middle of summer, it's no longer a dry spell. It can be, it's more often than not a small, not severe, but it's a substantial drought. So if you're into cherries, you cannot afford in Michigan to have one orchard anymore. You got to spread your orchards throughout the whole state so that you hope some of them produce, because some are going to be dinged by early spring and frost damage. Some are dinged by dry spell that is now becoming hotter and therefore more damaging to your crop. Okay, but out west, it's severe. It's a trend down in the river flows from the Missouri down to the Colorado to the Rio Grande. Little or big, all of them are going through this. Next slide. So where is everyone going to get the water? My colleague Jay Farmaghetti thinks we'll just go drain the Great Lakes. No, we're not going to do that. We have a Great Lakes Compact, which is not bomber, but you're going to have to convince all the states in the region and Canada that it's okay. And even if somehow we all become red states and go along with this deal, Canada's not going to go along with it. The problem is the Great Lakes have a very delicate hydrologic balance. And my colleague Drew Gronwald, you've probably heard him talk or seen him in the news. If we start taking water out of the Great Lakes, we could turn them into empty water basins very quickly. And then they would never refill. It'd be like the Caspian Sea over in somewhere in the former Soviet Union. Okay, next slide, please. But it's worse than what I've been saying, okay? Because we also have this problem in the high plains. Who's driven through Nebraska lately, or Kansas, or Oklahoma, or Texas? Where there are farms, there's circular irrigation going on. Fly over any of those states. Look out the window, and you see these circles. They're using groundwater out there. In other words, rain-fed agriculture is never really feasible on a commercial scale in the Southwest. The Hopi and other indigenous groups managed to pull it off, but they were very susceptible to these big droughts. Less susceptible than us, probably, because they were more clever. But once you get out on the high plains, you see the same thing. They're pumping groundwater. In the Southwest, that's what they're doing down in Arizona. We're turning off their supply of Colorado River water, and they're just turning on their pumps. As the groundwater gets drained, this is water that accumulated during glacial periods. Anyone notice any glaciers lately in North America? So this water is something that accumulated when it was cooler and moister in those regions. It's not sustainable. So this water just goes down, down, down. Cities like Tucson have subsided, 100 meters or more, I think. And it's sustainable now because we have Colorado River water, but we didn't before. But the biggest aquifers in the country, these are all the aquifers that have been studied, the big ones, that notice that they're all depleting. And the biggest ones are two different ones at different levels in the below surface on the high plains are also being depleted. So eventually, all this agriculture that's going on from 100th meridian westward, it's going to run out of water. And there'll be a few places like the San Luis Valley in Colorado where there's water because it's ringed by 14,000 foot peaks. But most of the places, they'll run out of water. And they'll still have 2 senators and 1 representative. So where are they going to get the water? Next slide. Where will they get the water? This is what got us to the Great Lakes. And I've already talked a little about why they won't get it out of the Great Lakes. So where the heck will they get it? And the big thing to realize is that 70% of the water used in the Southwest is used for agriculture. And that agriculture is like whatever makes the most money is what we grow. So for example, there's a lot of alfalfa being grown. A lot of dairy operations have moved to the Southwest. And because they can just pump water without any regulations. In Arizona, there are no regulations outside of the cities. You can just pump as much as you want. No one's going to do anything about it. That's freedom. And so you have a problem. Alfalfa going to our dairies, that's okay. We like cheese and milk and all that stuff. But is that really the smart way to use that water? Is it really smart to grow that alfalfa and send it to Saudi Arabia, which a lot of that water is supplying the dairies and the racehorses and I guess race camels? I don't know. It's going to the Middle East. Is that really a smart? We're exporting water in the form of alfalfa. So what should we do? And there have been studies now by people who have looked into this. About 30%, we can survive in the Southwest and do what we're doing now, even if the declines in water availability goes down about 30%. So we got a ways before it gets really tough. But they're going to have to make hard choices in how they use water. Have to make hard choices in how they grow. How many people have heard about the one community up off of Scottsdale that's already run out of water? A big thing is in the Southwest, and it's not a bad thing if done right, is water reuse. And I got a lot of grief once testifying before Congress because I said toilet to tap. And the staffers were like, don't say that. But that's what we're doing. We can reuse water. And we can reuse a lot of water, but you're going to continually lose water even as you reuse it. Okay? Big operations at University of Arizona and eventually at Michigan, I suppose, in the study of emerging contaminants. And it doesn't involve just figuring out what's in that water. A lot of stuff. How many people throw pills down the toilet? This happens all the time, and that's not so good for the people who have to reuse that water unless you've gotten that stuff out. But what stuff do you have to take out of the water to make it safe for our drinking? That involves our medical community, our public health communities, involves our engineers. It's a big deal. And in Arizona, they're doing it. But in other states, they will be doing it. Next, please. Oh, Great Lakes. Just remember, back slide one. Thanks. I put this on there just to make sure I remembered. What an amazing resource we have here. 20% of North America's surface fresh water. 20%. No, that's the global number. It's 80% of North America's surface fresh water. So this is an incredible resource. So right now, one of the things University of Michigan is gearing up to do, And it's no longer one school or another school saying this is what we're going to do. This is what the University of Michigan is going to do. We're going to work together to save the Great Lakes, to stop climate change, to transform our agricultural systems, to pollute less, use less water, and hopefully clean up the Great Lakes. You'll see in a minute in a slide what I mean. But we have to learn how to use our natural resources much more carefully in order to bequeath future generations a planet that has got the support systems that are necessary. Next slide, please. This is another, I only want to show you two really new things. One was, people clamoring for our water and let's drain the Great Lakes. This one is just came out just a couple weeks ago, 2 weeks ago, I think. It's a NGO that looks at climate risk, and they publish this map, and they go in and zoom in at the county, almost the county level, of where there's a risk of climate extremes costing us a lot of money. Meaning it's the intersection between climate extremes and infrastructure. And it's an interesting map because, right, look at the Southwest and the West. No problem out there. In other words, the infrastructure that's out there is burning up, yes, but not a lot of infrastructure is being destroyed. Livelihoods are being destroyed. Farms are being destroyed. Forests are being destroyed, but not infrastructure, human-built infrastructure. Whereas in the eastern United States, we have lots of infrastructure, and it is at risk. And same thing in China and India. It's interesting, Africa, no problem. The reason being no infrastructure. So that's another thing to really pay attention to. This gets in the headlines. It's like Africa's okay. There are a lot of people dying in Africa right now in the Horn of Africa because of global warming and drought. People are just, it's a humanitarian crisis, okay? But there's no infrastructure. So you got to really look at climate change with multiple lenses to see how people are actually affected. Pakistan, people remember what happened to Pakistan last year? Unbelievable damage, but not a lot of infrastructure. But I wanted to highlight this because we have infrastructure and we're at risk. What do they mean? Next slide, please. That's because we've talked a lot about the sponge getting bigger and soaking up moisture and causing more arid conditions everywhere around the planet. It's also going to rain harder when it rains, when the meteorological conditions, when that thunderstorm or that hurricane is squeezing the sponge, it'll rain harder, and that's what destroys infrastructure. Next slide, please. It's not just the extremes. As the storm, what's going on in the west, the reason the precipitation is going down in the southwest in the Colorado River Basin is because storm tracks in the winter are preferentially moving northward. Not every storm, not every year, but over the course of time, more and more are moving further north. And because of that, they're coming here instead of raining out or snowing out in the southwest. And so we've seen a really dramatic, all the green areas on this map are the areas where it's raining more on average. And the dry areas, you can't really see it, but the southwest is drier. The whole southern tier is kind of drying out while the northern tier is getting more. There are parts of the rain shadow of the Pacific Northwest that are getting drier too. So, there's other things going on, but all things equal, the jet stream and the storms are moving north. Next slide. This is the real eye-opener to me. This is the percent change in the amount of rain and snow falling in the most extreme 1% of the events, the most extreme intense events. It's gone up 42% in the Midwest. It's gone up even more in New England, in the eastern. It's even gone up a little out west. Around the planet, it's going up everywhere. And we're one of the worst spots on the map of the globe where precipitation is going up. Pakistan had a problem because they had this problem associated with the monsoon in Asia, the biggest monsoon in the world. Summer rainfall is getting more intense. But they're also getting the melting of glaciers, and they have lots of glaciers in Himalaya. And they're all melting at unprecedented rates. So you had the meltwater coming down the rivers, already full. Then you got the monsoon, more intense because of the warming. That's why you had the huge problem in Pakistan. Next slide, please. And just to see, things that we're all familiar with, living here in Ann Arbor in Michigan. More flooding in Detroit. Now we're getting multiple flood events a year. The infrastructure is not designed for this kind of storm. They're designed for the storms when the infrastructure was built. Engineers did a good job back then. They just didn't anticipate that climate change would really be supercharging the storms. Next slide. Dams bursting in Michigan. These are all problems that we worry about, not just in Michigan, but are worldwide. But they're happening here already. Next slide. Farms are getting flooded. You can't get your tractor out and start farming in the spring because the soils, maybe they don't look like this, you need a boat, but they're really waterlogged because of the increase in mean annual precipitation and then these storms dumping more moisture in the early parts of the summer. Thunderstorms are bad, but the springs have been really wet. It's been a dry winter here. This is mostly in the winter and spring. This is an anomalous year for sure across the United States. Next one. And the other thing, which I think most people in the room know, is we've got these harmful algal blooms, literally toxic algae that you do not want to swallow. And U of M scientists have figured out is actually blowing in the wind now. You certainly don't want to breathe. Good for you, wearing your masks. You're safer with these harmful algal blooms, not just COVID. But these blooms are now starting to see them in every single Great Lake. All the shallow waters increasingly are at risk of these harmful algal blooms. Why? Because we're two things. One is we're pumping more nutrients into our streams and rivers, getting into the Great Lakes. Why? Because we're getting more precipitation, raining harder, more runoff. The other thing is, darned if these algae don't like warmer waters. And the Great Lakes are warming up like never before. They're warming up much faster than the air. So we're killing the Great Lakes. Next slide. So I don't want to talk forever, even though it seems that way. To conclude, I'm going to take some questions if we have time. But we're already getting a lot of impacts in the United States. I would maintain many parts of the world, places where they did not contribute many greenhouse gas emissions. They're getting worse. They don't have the money and the infrastructure and know-how necessarily to deal with these extremes. They're getting hit harder than we are, but we're getting hit hard in the United States already. We have high confidence that as long as we keep warming, this is going to keep getting worse. And we need to stop the climate change fast. The current administration is the first administration that's putting serious money and effort behind this. It's fantastic. It's really good for Michigan. Great that our governor and our legislature really understands that. Great that Ann Arbor and leaders like Missy Stouts, a SEAS alumnus, understands that. We're trying to move fast on climate change, but we're not moving fast enough. So that's one of the big priorities, I hope, with our new president and working together across campus, the deans are all interested in doing, is seeing what a big research university like University of Michigan can do to speed it up. And at the same time that we're trying to fight climate change and stop it, we have to learn to be more resilient in the face of the climate change we cannot stop, the kind of climate change we're already dealing with. And we have to do this at home, and we have to figure out how to help people around the world also be able to be more resilient. Because it's going to cost a lot of money, it's going to cause a lot of conflict, it's going to cause a lot of migration. It's already happening, so everything I'm saying is no longer hypothetical, it's real, it's happening. But we have real interest in this country to stopping it and to learning how to adapt to what we cannot stop. And this is one of those things that the University of Michigan is really going to lean into. And SEAS, my school, is going to really try to be at a forefront in helping to lead this effort. But it's all our colleagues across the whole university, including nursing, the medical school, kinesiology, music, theater, and dance. Ask me questions. All of them are going to be contributing to this. So with that, I'll stop and say thank you.
time for a few questions. So, Dean Overbeck, this was, I mean, it really reinforces what President Ono was talking about in a very concrete way. So, thank you very much. Questions?
See a hand over there. She's getting away.
Oh, yeah.
I'm not trying to put you on the spot exactly, but I noticed the school you didn't mention was the Ford School of Public Policy.
I'm going to stand on a spot right here. I think that's great. Thank you for doing that. I'm actually helping. I'm on the search committee for the new dean of the Ford School. And the Ford School is like a central partner in all of this. And I'm sorry I didn't mention it because I didn't really have time to go into other schools and what they could do. But we know, thanks to great engineers and great ecologists and great this and that, a lot of the solutions. We have the solutions to tackle the problem. We have the technology. We're going to continue to improve it, make it less expensive and all that. But the big problem is that we don't have the policies that are moving this process fast enough. And so our colleagues in C's, we have policy people. In Ford, we have economists. They all work together, and they're in LSA too. I've made a proposal with a group of deans to create a think tank-like operation at the intersection of the University of Michigan and policymakers in Lansing, policymakers in Ann Arbor, policymakers in Washington, policymakers everywhere, to help policymakers craft the tools and get the support behind their policies to see them implemented. So a big part of this, and this is where music, theater, and dance, for example, comes in, or the arts and humanities, is how do we inspire Americans to pay attention and to support the policies that are needed to implement the solutions. That's a big part of what I think the University of Michigan and other universities can do. When I say other universities, I mean across Michigan. Many of you know, you go up north and you got a lot of people that go like this, that don't have the Michigan flag out front, to University of Michigan people. You know, we're that big elite group, liberal group down there in Ann Arbor. Well, we can work with our colleagues at the other institutions of higher education, the community colleges, the little colleges, the big ones, universities, to all use our trusted relationships to speed this up. And some of that will be storytelling, and some of it will be music and theater and dance. Some of it will be engaging in ways that are less politically confrontational. And we'll have to learn how to do that with our colleagues at the Ford School. Ford School will play a huge role, and the interim dean is Celeste Watkins. Tell me her last name. I feel embarrassed. She's been right in the middle of this and has been very helpful in understanding. And some of my colleagues in the Ford School have been right at the, that's where the idea came from. To really lean in and do more in the policy interface between the university and our elected leaders. I hope that helps a little. Any other questions? Yes.
You put in a lot of time with the University of Michigan President's Commission on Carbon Neutrality. I'm surprised you didn't mention it. I want to invite you to mention it to this audience. Do you think it will succeed in getting the university to carbon neutrality? And more importantly, do you think it will have impacts that extend beyond the campus to help other communities and other universities move towards carbon neutrality?
Absolutely, on both counts. When we presented our plan to Mark Slissel, the former president, and there's some controversy around Mark, but I'll tell you, on carbon neutrality, he is a hero. He's like talking to us in one-on-one. There was a lot of lobbying, and I'm sure a lot of community members were lobbying too. I know that, and students and faculty. But he's like, Peck, if I commit the university carbon neutrality, that's a huge decision, because the University of Michigan, when one president makes a commitment, every other president is committed. That is the tradition in Michigan. We're not one of those wishy-washy universities where one president says, okay, we'll do this, and the next president says, no, we can't afford it. So I have absolute confidence But moreover, the new CFO of the University of Chattis he's already sped up what we proposed. And then you got Santa Ono coming in, who is probably going to declare a climate emergency. That's just a guess. He hasn't told me that. But, that's what he did at UBC. He's going to make this a big deal. And we look at what we're doing with our endowment. Everyone else is like, we're going to divest of fossil fuel and this and that. The University of Michigan is already, I didn't even notice who made the decision, but someone made the decision in the last couple of months. We're taking our endowment carbon neutral. We're going carbon neutral on scopes 1, 2, and 3, and that's tech speak for everything. No other university, particularly a big university, is doing that. None. We're being realistic, though, that it's going to take until 2040 before we're carbon neutral. The reason for that is we're at high latitude. We have to do this in a cost-effective way. It's going to cost billions. But how do you heat in the winter when you get one of these polar vortexes, which are going to continue because essentially we're destroying the sort of buffer between the Arctic and the lower latitudes, so this cold air can break it down and come down here just as our warm temperatures can get up to northern coast of Greenland. We need to be able to heat in very cold temperatures periodically, and two ways to do that. One is to overbuild your renewable energy by 300%. The other way is to use ground source heat pumps, shallow geothermal. And that's why we put in the plan geothermal. It's a cost-effective way to do the job. And we're also thinking that by 2040, we're all praying actually, there'll be additional technologies. And we have a new Institute for Energy Solutions. We have we have a lot of new entities, a new hydrogen center on campus. And my faculty are involved in these. Engineering is heavily involved in these. We're going to find new solutions that hopefully will make it cheaper and easier. But even if you follow just what we said we'd do in our plan, by 2060, the university breaks even and then starts saving money. So it pays back, and it doesn't cost us a penny in the long term. And that's one of the great things about universities. We're here for a long time. And hopefully, yes, once we do this, we're doing ground source heat pumps because Ball State did it. We're just doing it at a much bigger scale. And we're going to show everyone that that is very feasible. And all these other solutions. The big thing is the policy issues. How do we get DTE and consumer energy to stop fighting every frickin' solution that we come up with? They're just trying to slow it down. How do we get Exxon and Shell to stop being bad guys and to start being part of the solution? That is going to take, I think, carrot and stick.
Speaking of carrot and sticks, etc., the U.S., etc., is doing a great job. But how do we convince other countries like India and China? I think they're producing more emissions than we are, and they're building more coal plants every day.
It's Celeste Watkins Hayes. I just want to go on record. I remembered. You all know this feeling, right? When you start getting you get this gray hair, you start like, what was their name? But anyhow, Celeste is she's a hero in this space. China and India. I actually think we're in a race with China and India to control market share on solutions to climate change. Those two countries, particularly China, is investing huge amounts of money in fighting climate change. Yes, they still have coal-fired plants and this and that, but check out how often those coal-fired plants are fired up. Increasingly, they've got them. They're not turned on much of the time. They've got some problems in the way their provinces have to compete against each other, and the way they want to source their energy and develop jobs and economy, GDP, within their provinces at the expense of smarter solutions by transferring energy between regions. It's like having a whole bunch of Texases, Texas doesn't want to work or cooperate with anyone. Well, they got slapped pretty hard 2 winters ago. And that will continue to happen until they interconnect with the rest of the country. But we really need to interconnect all the way in this country so that when we have a problem with energy in one part of the country because the wind's not blowing enough or the sun's not shining enough, we can just get it from another part of the country. Arizona is going to win out here if they actually can get with the policies to encourage solar more. They will become it won't be Texas that has all the solar. Texas has the most wind and solar. It's amazing. India is another very interesting case. Whereas China is trying to be the grand supplier of the global economy and be the sort of ultimate endpoint of everyone's supply chain, we're shifting gears, thanks to the new administration, to do that here in the United States. And I'm not going to get into whether that's good or bad, but I'm just saying there's some good aspects. India's taking a whole other approach. They don't want to be beholden to anyone's supply chain. And they're going to try and develop their entire supply chain for climate action in India. So in each case, China, India, and now the United States, the deployment of renewable energy and other solutions, clean tech, is increasing at an exponential rate. So I'm not worried about, and look what happened in Europe. Putin's little gambit backfired. They're now decarbonizing even faster than they had planned before and getting out of gas faster than they had planned. Not for any reason other than geopolitical. There's a lot of good news in this story, but you can't just sit back and say everyone's moving fast, because we're not moving fast enough.
Hi, I'm Shakir Katafian, a retired faculty here. I have two questions, somewhat interrelated. One is, we have a very large student body who are studying one of 21 or plus disciplines. What steps will you be taking to engage the students in all the disciplines, regardless of whether they're from your school or not? Because these people will go out to start working out there, and they can be missionaries for the climate. Same with the faculty of every discipline. This is a human issue, not a disciplinary issue. So the other point is sort of difficult. I visit the West Coast frequently, and I talk to people, and everybody seems to think that it's the responsibility of the government, you see, to solve this problem. Instead of, there's no sense of personal responsibility that I have heard articulated. But why do I have government? What are they doing, they say. So those are the two things.
Well, you guys have academic environment here. We're asking tough questions. First, the reason I stressed over and over again that we're working not as individual schools, but as a campus, and literally the deans, every single one of us is working, there's 19 of us, we're working together. We're coming up to our next campaign. You all support the campaign, right? We're working on our next campaign, and we are obviously going to be working on behalf of our own schools and colleges, like it's always been in the past. But at the same time, we have a whole bunch of what we call bold ideas, which are working together. And one of the 5 themes is saving the planet. And in that theme are a whole bunch of things, like saving the Great Lakes and saving, basically stopping climate change and adapting climate change. But there are other, in more sustainable food systems. There are a bunch of others, environmental justice. They aren't C's themes. They are C's themes, but they are every other school's themes as well. We're going to be fundraising together for these. And I think the new president is like, that's what he wanted to see. And if we hadn't started that 3 years ago, when Mark Slissel kicked it off, and it was really the deans who wanted to do it, no one had to kick us to do it. Ono would have forced us to do it, I think, because that's the only way the University of Michigan has more impact than we have now, is to work together. We have all these programs who are the top programs, over 100. They're top-ranked programs in the country, and each one of these programs have amazing students. And so there are so many professional schools and non-professional schools where the students are heavily involved in research. They'll be involved in research and engagement. Capstones, engagement. So we're not only we're gonna give them experiential learning, internships, capstones, all these different ways we can find so that they will leave University of Michigan armed to be not just disciples and spokespersons pushing, but have tools in their careers, whatever those careers are, nursing, medicine, and of course the more obvious ones, where they will be pushing. There'll be activists, not just people working from within. There'll be activists from social work, from Cs, from other schools, who will be out there forcing the banks and forcing the DTs of the world to get real on climate change. So they'll have the tools. We are already implementing, next week even, there's a new, all the associate deans, not all probably, but most of the associate deans for academic affairs from across campus have arranged to have a big 2-day symposium on teaching climate at the University of Michigan. So the idea is to infuse climate action, climate knowledge in everything we do at the University of Michigan, not just to create new classes in PIPE or in earth and environmental science or space and climate engineering, but literally in every single class that is possible to touch on climate. And we already are up in the hundreds of classes that do that already. So we're going to just, hopefully the momentum will continue to pick up. It'll be like an exponential increase in what the University of Michigan does to empower all our students. Now, what was your second question? Oh, the government. Well, right now the government's doing a lot, bless their hearts. I think there's literally a gold rush going on in America. Private sector is also really critical to solving the problem. And the government has now given the private sector a lot of incentive. I don't think it'll be enough to meet the Paris goals. And hopefully I'm wrong, but hopefully we'll be able to find other ways to accelerate even more. But the government in the United States is doing an amazing job. Of course, there's now a new House of Representatives in Washington that is going to try and tear all that down actively. But hopefully the government will continue to do it. We also, like I said before, we have to inspire Americans to all do more. And how we inspire is something we have, figure out at a university. And it won't be people like me. I actually spend a lot of time working with stakeholders, building relationships, building trust. But we have to figure out a way to accelerate that and make sure everyone who can does more to solve this problem. And the most important thing is to vote. That is the most important thing. We have to vote for the people who make climate change a priority, like the current president of the United States, and not someone who makes it a third priority. It has to be number one priority. And this transition has to be just. So justice has to be right at the lead. And again, our present administration is doing that. Our 4 faculty working in the Biden administration are all environmental justice experts. We are basically, University of Michigan, are the ones behind the president's environmental justice efforts. And they are immense. Are they enough? Probably not. We have to keep pushing. And that's what the University of Michigan has to show how to do, and hopefully other universities will follow us. We're going to work with MSU. We're going to work with Ohio State. Yes, Ohio State. We're going to do this together. Okay? That's the solution. We got to put aside it's okay on the football field or the basketball court, but when it comes to solving the world's problems, we have to work together. And I think the new president gets this. I think the deans get this. The provost gets this. The University of Michigan is poised to start doing it. Our job. And we are supposed to be leaders in best. I'm not a big fan of that moniker myself, but let's figure out a way to lead. Show people how this really works for our students, it works for our faculty. And hell, if we didn't do this, our students would be up in arms. It's going to be like the 60s again if we don't watch out.
Thank you very much. And I would like to add, don't leave the retirees out.
No. You guys think of all the time you have. I know there's some people in the room doing things already. The regents are on board, okay, with all of this. Even on both sides of the aisle. And, they recruited an amazing president. And so, but, we got to keep the pressure on everyone. Keep the pressure on me. Keep the pressure on all our leaders in this university. That's something you can do. Keep the pressure on your electeds. That's something you can do. Vote. Get out the vote. That's something you can do. Okay? There's a lot that we can all do. And I think retirees, all the time in the world. I can't wait.
Thank you very much. It was an inspiring talk.
Okay.